So chapter 8 deals with confidence intervals. Now, a confidence interval is something that we use whenever we have an unknown population parameter. What it allows us to do is give an estimate and a range of values, an interval of values which we believe contain the actual population parameter here. So it's made up of two distinct parts. One of them is what we call the point estimate, and the second part is what we call the margin of error. Now, the point estimate itself, if you want to think about it, is sort of like your best guess as to what you believe the parameter is. All right. Now, it's not something we just pull out of air. It's something that we actually kind of calculate by using the information that we do have available to us. So what we would do is we would pull a sample from our data, and then we would use the information that's obtained from that sample to create this point estimate. So if we were looking at a population mean, we would use our X bar. If we were looking at a population proportion, well, we would use our P hat. So a point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called the point estimate. So ideally, the point estimate is our best guess at the value of this unknown parameter. Now, we want this estimate to have no bias and low variability. But since it's coming from a statistic, we know that every time we pull a sample, we are going to have a different value for that statistic, a different X bar, a different P hat. So instead of us just using that one value to say, oh, I believe the population parameter is this, we use that value instead to create an interval or to create a range of numbers that we believe the true parameter is actually inside. So here would be an example. What point estimator would you use? The makers of a new golf ball want to estimate the median distance the new ball travels when hit by a mechanical driver. They select a random sample of 10 balls and measure the distance each ball travels after being hit by the driver. Here are the distances in yards. So we have the distances here of the 10 values. So what we're going to use is we want to take these and we want to average them. And we're going to get our X bar. Now this X bar would be our point estimator, and I believe it's 285 yards. And this would be the value that we actually use to build our confidence interval around. Now, the golf ball manufacturer wants to know what proportion of the golf balls are defective when they come off the line. They take a random sample of 100 golf balls and find 13 are defective. Okay, so this is the data we're going to use in this case. We're dealing with the proportion, and we know we've got a sample, so it's going to be our P hat, which will be our 13 over 100 or 0.13. So that'll be what we actually use to make our confidence interval. That would be what we call our point estimate. So once we have that point estimate, we're going to create, like I said, that interval. Now we want to put some confidence behind that interval. We want to be able to say that with confidence that we are a certain % sure that the true value is within that interval itself. So we've got a couple of vocabulary words here we want to look at. So a confidence interval for a parameter has two parts. It's made up of that estimate or that guess plus or minus that margin of error. Now that margin of error is going to basically tell you how close the estimate tends to be to this unknown parameter. Okay? And then that margin of error is made up of what we call our confidence level or our C. This is the overall success rate of the method. So it's basically the C% of all possible samples the method would give an interval that captures that true value. Now, usually we want this to be a relatively high value. We choose, a 95% confidence or higher because we want to be very, very sure of our conclusions. So the most common one that we use is actually a 95% confidence interval, and we'll go through the process of how to actually calculate that a little bit later on in this chapter. So kind of explain this a little better, give you a little visual of how this works. So let's suppose that we have a population proportion, that the true proportion of something that we're looking at is 0.5. And let's say we want to create a 90% confidence interval. So we're going to pull our sample is going to be of size 100. I'm going to pull a sample. Now if you notice, the P hat was 0.44, and then we've got this calculated margin of error for our sample. So if I pull another sample, you see the P hat changes 0.43, but you can see that it still hits on that green line. That green line is still maintained inside of it. So we're still, our interval still contains that actual value. Let's try another one. So we have another one. And another one. Let's go ahead and pull 25 of these. And you can see out of 25 of these, we had one that did not hit the actual interval. So what happens in reality is we really don't know where that green line is. But if we pull multiple samples, we can see that of all of them, 90% of them, actually over 90%, 96.96% of them actually contained the value itself. We pull another, and now we're at, you can see at 92. So we have 3 that actually did not hit. So we can try a different confidence level. So let's change our confidence level down now. So 85. So that means that if I were to do 100 of these, then about 85% of them would actually contain the value. So you can see we've got 1, 2, 3, 4, 5, 6 here of them. We know that if I look at our percent hit here, 84% of them actually contained that true value. So that's the way that confidence interval and confidence level works. So this level tells us if we were to repeatedly sample how many of them or a percent of them that would actually contain the value itself. So think of the confidence level as an overall capture rate if we use this method over and over and over and over again. So when we interpret our confidence levels and confidence intervals, confidence level is to say that we are 95% confident is shorthand for saying 95% of all possible samples of a particular size from this population will result in an interval that captures this unknown parameter. Now with the interval, what we would say is to interpret the interval, we are 95% or blank percent confident that the interval from blank to blank captures the actual value of the population parameter. This sentence down here is something that we are going to kind of use as a model of how we interpret and actually write our values, write our conclusions when we actually do our problems here. So the confidence level tells us how likely it is that the method we are using will produce an interval that captures the true parameter if we use it many, 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 many times. It does not tell us the chance that the particular confidence interval captures the actual parameter. So let me repeat that. The confidence level does not tell us the chance that the particular confidence interval captures the population parameter. Okay? Because the parameter itself is either in the interval or it's not. Right? So it's either a 0 or a 1. Right? But what it does is the interval itself gives us a set of plausible values. So remember, the level tells us that if we were, how likely it is that the method we're using will produce the interval if we do it many, 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 many times. And then the interval that's created gives us a set of plausible values for that actual parameter. So we've got the basic formula here, which we know is our estimate plus or minus our margin of error. Now I told you that margin of error is made up of 2 parts. The margin of error is made up of what we call the critical value and the standard deviation of the statistic. Now the standard deviation of the statistic is sometimes also referred to as the standard error, or SE. All right, now that formula right there is our basic formula, and we'll build all of our intervals off of that. Now as you can see, if you think about it, the critical value is based off of the confidence level. So we've got our 80% confidence level and our 95% confidence level. Well, the more confident we are, the bigger our interval is going to be. Because we are more confident, therefore we're going to include actual numbers or more actual values there. So the margin of error is going to get a lot smaller when we decrease that level of confidence, or the sample size actually increases. So one of those 2 things are what we do to make that margin of error smaller. Now normally we're not going to want to decrease that level of confidence, so what we're going to want to do is increase that sample size so that it gives us a closer value to what the true true parameter actually is. Now, of course, there are conditions in order for us to do this, and they're the same conditions that we've been using. It's our random, normal, and independent. So the data must come from a random sample, right? Then our normality, this is the same normality conditions that we used before. For our means, we want the central limit theorem to apply. Therefore, our sample needs to be bigger than 30, And for proportions, we want that NP to be greater than 10 and that N times 1 minus P to be greater than 10. And then we have our 10% clause, which is our independence clause. So the conditions are not really changing that much from what we've done in the past. So there's a 4-step process that we use. First thing we always do is identify our population of interest, all right, the parameter we're drawing the conclusion about. Then we're going to verify our conditions, we're going to carry out our procedures, and then we're going to interpret our results. Now this is that kind of pat sentence we're going to use anytime that we actually interpret our results. So you may want to write this down. We always say we are blank % sure that the true mean of blank is between, this is our interval here, based on a sample size of this value. Now, of course, this mean may change to proportion if we are dealing with proportions instead of means, but it's the same basic sentence every single time that we actually do this. So that's the basic idea behind a confidence interval. We'll talk a little bit more about it in class if you have questions, but that's our basics for building that and constructing that actual interval itself. Have a good night.